Have you ever wondered where life really begins? Not on Earth, but far beyond, in the cold, dark void of deep space, before stars are born, before planets even exist. Now imagine this. A young star, still forming, suddenly flares with radiation, and in that moment reveals a stunning truth. Inside the swirling disk of gas and dust surrounding it lie the very building blocks of life: sugars, amino acids, even fragments of DNA. What if life didn't start here? What if it was always meant to be? This is the story of a baby star called V883 Orionis and the groundbreaking discovery that has astronomers stunned. The star that shouldn't matter. In the grand theater of space, some stars are loud, supernovae, pulsars, black holes, but V883 Orionis was not supposed to be one of them. It's a protostar, a baby star still forming inside a giant cloud of gas and dust, about 1,300 light-years away, nestled deep in the Orion constellation. Astronomers have seen hundreds like it, but something was different. This star suddenly flared, erupting in a rare outburst of heat and radiation, and that changed everything. Because in that moment, ice, once frozen solid across the dusty disk, began to melt, releasing gases never seen before. Astronomers turned to the most powerful observatory ever built for such mysteries, the Atacama Large Millimeter Submillimeter Array, or ALMA, located high in the deserts of Chile. And what ALMA found defied all expectations: the hidden chemistry of life. Inside this young disk, scientists detected 17 complex organic molecules, not just basic gases. We're talking about chemicals like ethylene glycol, the same family of molecules used in antifreeze, but also tied to sugar formation in biology. And more importantly, glycolinitrile, a rare molecule that acts as a chemical precursor to amino acids like glycine and alanine, and even adenine, a key part of DNA. This was the first time in human history such life-related molecules were found in a planet-forming disk. Let that sink in. Before any planet had formed, before there was land, water, or atmosphere, the seeds of biology were already floating in space. This wasn't just dust and gas anymore. This was prebiotic chemistry, alive with possibility. The old theory, now broken. Until now, astronomers believed something very different. They called it the reset hypothesis. The idea was simple. As stars form, they undergo violent phases, ejecting matter, blasting radiation, triggering shock waves. These chaotic events were thought to destroy any complex molecules formed earlier, essentially resetting the chemistry of the region. In other words, by the time a protoplanetary disk formed, life's ingredients would have to start over from scratch. But V883 Orionis just shattered that idea. These complex molecules survived the violence. Not only that, they may have even formed during the chaos. That means, instead of a reset, we're looking at a continuum, a cosmic chemical evolution that stretches from interstellar clouds to planetary birth. The implications are staggering. How did these molecules get there? To understand the full picture, we have to go back, way back, long before planets, before stars. There were just cold clouds of gas and dust. In these icy conditions, certain atoms clumped together on dust grains, forming simple organic compounds. With time and radiation, especially ultraviolet light, these compounds grow more complex, but they remain frozen, locked away in ice, until something heats them up. In the case of V883 Orionis, it was a massive outburst from the forming star. This outburst acted like a cosmic oven, suddenly raising the temperature across the disk. The ice sublimated, turning directly into gas, and released a hidden library of molecules. That's what ALMA picked up. The spectral fingerprints of chemicals once buried in ice. It's like the star itself reached out and whispered a secret. Life might begin long before you think. What this means for us. If these molecules exist in one star's disk, how many other stars carry the same legacy? Because here's the twist. The same chemicals, glycine, alanine, even adenine, have been found in comets, asteroids, and meteorites within our own solar system, which raises a profound question. Did Earth inherit its life-building molecules from space? Were the seeds of DNA delivered to our planet by ancient comets? And if so, is the same story playing out elsewhere, across millions of planetary systems, right now? This isn't just a story about a star, it's a story about how common life might be in the universe. universe, the bigger picture. Let's zoom out. We now have a chain. Cold interstellar clouds form simple molecules. As stars ignite, their radiation helps build more complex compounds. These compounds survive the protostellar chaos. They end up in planet-forming disks, like V883 Orionis. Eventually, they get locked into asteroids, comets, and planets. This chain doesn't stop at Earth. It could be happening everywhere, in every galaxy, every star nursery, every icy disk. If these molecules are universal, then life may not be a miracle. It may be a pattern. So what does this all mean? It means we're no longer asking, is there life out there? We're asking, how many times has life begun? Because V883 Orionis isn't just a young star, it's a time capsule showing us how life's story may begin, not just here, but everywhere. It means the chemistry of life may be written into the fabric of the universe itself, and that we, the thinkers, the questioners, the watchers of stars, we may not be alone in our beginnings. The seeds of life are out there, waiting. If this discovery blew your mind, let us know in the comments. Do you believe life is rare, or is it written into the stars? Don't forget to like, subscribe, and hit the bell, because the universe is just getting started.